Today's chapter is general equation of second degree and classification of conics. So first starting with the general equation of second degree, which takes the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. This is called general form of second degree equation. Check the highest power of x or y, or if you check this term also, highest degree is 2. That's why this is called second degree equation. Now throughout this chapter there are only one type of problem, which is the classification of conic. You will be given one example like this. You have to find out which type of conic it is, then you have to find out its canonical form. So for that reason, whenever you get such type of question, at first what will we do? We will compare with the given equation. We will compare and get all the values of a, h, b, g, f and c. These are the total 6 constant. You have to find out these values by comparing the general equation with the given equation in the question. Then you have to calculate two value. First is delta. This is the determinant a, h, g, h, b, f, g, f, c. And then another which is called d, which is a, h, h, b. So after getting the equation and then after getting the values of all the constants, you have to compute this determinant delta and this determinant d. Now here two cases can arise. Number 1, delta is not equal to 0, and number 2 is delta equals to 0. So if delta not equals to 0, here three cases can arise: d greater than 0, d less than 0 and d equals to 0. Now in that case, if d greater than 0, it's an ellipse. That is, the given conic is an equation of an ellipse. If d less than 0, it's an hyperbola. And if d equals to 0, it's a parabola. You all are familiar with these three type of conics: ellipse, hyperbola and parabola. Okay. And the second case, if delta equals to 0, then also three cases can arise for d: d greater than 0, d less than 0 and d equals to 0. Then if d greater than 0, it will represent a pair of imaginary straight lines. Pair of imaginary straight lines. If d less than 0, this is a pair of intersecting straight line. And if d equals to 0, this will form a pair of parallel straight line. Okay, so from this table we can easily get that what type of curve it is given in the question. If at first by computing delta and d, check delta not equal to 0 or delta equals to 0, then calculate the value of d, and according to the value of d we can easily get that what type of conic it is. Okay, this is the first part of the question. Now the second part, you have to find the canonical form of that given equation. So for that reason, there is only one procedure for each of the problems. So check, we will consider when the cases when delta is not equal to 0 and d is not equal to 0. Then we will start it with a particular example. It will be easier for all of you to understand. Example 1. Reduce the following equation. Reduce the following equation in its canonical form. And find the nature of the conic. Find the nature of the conic. And the conic is 3x square plus 2xy plus 3y square minus 16x plus 20 equals to 0. Okay, so this is our given equation. So what is the first thing we have to do? At first we have to compare it with the general equation of second degree. Comparing it with the general equation of second degree, which is ax square plus 2hxy plus by squared plus 2gx plus 2fy plus c equals to 0. Okay, now if you compare all the coefficients. So x square's coefficient is a and here it is 3. So a equals to 3. Then xy's coefficient 2h, here it is 2. So h must be 1. Similarly, b is equals to 3, g is minus 8, f is 0 and c is 20. Okay, so we got total 6 constants. Now we can easily calculate delta and d, that two determinants. So moving to do that. Delta is AHG put the values. A is 3, H is 1, G minus 8, then H is 1, B is 3, F is 0, minus 8, 0 and 20. Now I hope all of you know how to expand the determinant. If you do that, we will get answer will be minus 32. Clearly this is not equal to 0. So clearly this is minus 32, which is not equal to 0. Same calculate D, which is this value will be 8. If you put all the values and simplify it, will be 8. Clearly this is also not equal to 0. So in that case, both the delta and D is not equal to 0. That means it's a central conic. Now you have to find the value of alpha comma beta, which is called the center of the conic. So let the center of the conic be alpha comma beta. Then how to find alpha comma beta? You just have to consider the first two rows of that determinant delta and take A alpha plus H beta plus G equals to 0, this equation, and H alpha plus B beta plus F equals to 0, this equation. So if we consider it, we are getting A alpha plus H beta plus G equals to 0 and H alpha plus B beta plus F equals to 0. That means we are getting, put the values of A, H, G and all. So 3 alpha plus beta minus 8 equals to 0, and then alpha plus 3 beta plus 0 equals to 0. So these two equations we can easily solve it, linear equations of alpha and beta. After solving, we are getting alpha equals to 3 and beta equals to minus 1. So this is the center of the given conic. Okay. Now that means at this point center we are shifting the origin. Like the transformation of axis, we have already learnt about it. So at that point alpha comma beta, we are shifting the origin. So the new equation will become ax square plus 2hxy plus by square plus delta by d equals to 0. Okay. So put the values, it will become 3x square plus 2 into 1 xy plus 3y square, and delta by d, calculate its value. It will be minus 32 by 8, that is minus 4 equals to 0. Okay. So after translation we got this equation. Now we have to apply rotation. That means by rotation we want to remove the xy term from this equation. So to remove xy term from this equation, we apply rotation by the angle theta. We apply rotation by the angle theta. So we know the formula for rotation, which is x equals to x dash cos theta minus y dash sin theta, and y equals to x dash sin theta plus y dash cos theta. We will apply it in our new equation, which is 3x square plus 2xy plus 3y square minus 4 equals to 0. So if you put it, you will get 3 into x dash cos theta minus y dash sin theta its whole square plus 2 into x dash cos theta minus y dash sin theta into x dash sin theta plus y dash cos theta plus 3 into x dash sin theta plus y dash cos theta its whole square minus 4 equals to 0. Now we want to remove the xy term. That means we need to consider the coefficient of xy term must be equals to 0. So find out the coefficient of xy term. If you want to expand it, then check the coefficient of xy term. You can do that, or without expanding also we can get the coefficient of xy term. Check, if you open this bracket, you will get a square plus b square minus 2ab. So from there we will get 1 x dash y dash term. So that will be minus 2 into 3 into cos theta sin theta. Then from here, by multiplying this one and this one, you will get 1 xy term. That is, this will be plus 2 cos square theta. And by multiplying this one and this one, you will get another xy term. So it will get minus 2 sin square theta. And from here also, we are getting plus 3 into 2 sin theta cos theta. This must be equals to 0 because by rotation we want to remove the xy term. Now check, this and this will got cancel out. We are getting cos square theta minus sin square theta equals to 0. That is cos 2 theta equals to 0, which is cos 0, that is cos pi by 2. So 2 theta equals pi by 2. That means theta equals pi by 4. So this is the required angle. Now